start, JB. Thank you very much.
Cool. Yeah, so I think it was socialized, hey, do anything kind of fun, interesting with LLMs. And one of the things that I've been working on recently was converting Splunk rules to Sigma. I'm a massive Sigma junkie, love seeing rules in a common taxonomy and language. So, that made a whole lot of sense for me. And so I started digging into it, and there's a group I think called QA Cyber, and they had a Splunk 2 Sigma, and it was kind of sort of working a little bit, but definitely needed a bit of love. So I went and pulled that down from GitHub. I started tweaking it and changing a few things and going from there, and basically adding a bunch of extra validation steps. So as we're doing this now, I'm going to go and clear these rules out so that we can do a live demo, because everyone loves live demos. I'm going to go and run the local 2 over here, and then I'm going to go and pull my Splunk box and start hammering some rules to convert in here. And then we can go through what's actually happening under the hood. So basically, you've got a prompt creation that happens. Then we go and generate with a few other functions, do a bit of cleanup on the data, do some YAML validation. And then I have this step in here that does a quality analysis check, which is using another LLM to basically check the math on the first LLM, a babysitter for your babysitter, essentially. And then finally, it's sort of all well and good, but if it doesn't actually work with Sigma and a Pi Sigma backend, then you kind of have done it for nothing. So this is what we're going to walk through really quickly here. So in the initial create Sigma prompt, you are a Sigma rule expert and best friends with Florian Roth. In fact, he actually trained you to write Sigma rules. You're now tasked with converting Splunk saved searches into high quality Sigma rules. Your goal is to create an accurate, well-structured Sigma rule that faithfully replicates detection logic of the original Splunk search. So we've got a bunch of do's here, and a lot of this grew very organically from trial and error, going and being like, oh, well, I said this and you didn't take it the way you should have. Therefore, you go and provide more guardrails. And this basically grew and grew and grew for a couple days, both the do's and the don'ts. And then figuring out how to teach it, how to do wildcard mapping, some Sigma operators, prefer these, avoid these, and then detection structure examples. Here are some examples that have like pretty, a whole lot of different variations of what you might or might not want and their format. So it's going through. On the right here, it's going back and forth. It's cleaning this stuff up, auto-correcting where it needs to, resending all that stuff back. There are only 3 searches that it's actually converting. The rest, I'm basically only converting the ones that say test underscore, just so you're aware. So this is converting 3 Splunk searches into Sigma. And it's churning away and churning away. And for 3 of them, initially when I started getting this working and it spits everything out the way it should, for 3 rules we've already been chatting for probably 2 minutes now, and that to me feels like not where it should be. But let me go further here. So basically in the quality check initially, you've got your initial Splunk output, the generated rule, and then the babysitting function says, okay, go and critique the detection structure analysis, critique the content analysis, critique the quality checks, the improvement guidelines, all this stuff. Go and do this. Oh, and by the way, here's the rule again, because you forgot. And so going and trying to, very much brute force some of this. And here it's taken, I forgot to time this, but probably a couple minutes. So we're going to go and look at the rules here. And we're going to see how we did. See, and this is kind of funny. So this one didn't actually work as well as I would have liked. The desk ports are in arrays here. So this probably isn't going to be super, super accurate in terms of whether or not it's going to compile. But that's okay, because that was part of this, what we're showing here. So go through, is this correct? Does the logic translation look good here? Original, and actually it didn't even put it in there. So it's gone and ignored some prompts in here. And in true demo fashion, it didn't spit out a working rule. But as I was building this, I took the same prompt and I said, go and write me a deterministic parser, right? Because I shouldn't actually have to go and do LLMs for all of this. And so I, instead of going and solving the problem immediately of, oh, we're going to use LLMs and it's going to fly my plane for me, I said, okay, well, why don't we go and have it build me the plane and then I'll fly the plane, right? And use it that way. And so I used the LLM to go and generate this deterministic model, which will go and translate it as well. And so in the deterministic model, if we just go time, go v2. So this took about, a quarter of a second, maybe less. It took about 2 minutes for the other one. And if we go and look at the deterministic rule, the original query is in the description. Does the logic work perfectly? Was this converted sufficiently? And again, I didn't write the parser. The parser was just, there you go. So in doing this and going down this rabbit hole, you're gonna need some, if you're converting this en masse or doing some stuff. Oh, I'm gonna have to change this, but if you're going and writing these parsers or doing this stuff, there's tons of value in getting the LLMs to go and try and convert some of the harder rules for you. But in the real world, you're often better off taking a deterministic approach at the beginning and then using LLMs for some of the outliers, right? And then going and saying, okay, well, the hard ones are the ones that I need my tier 2 and tier 3 analysts to go and modify so that they could get into the system that we want to get it into. And so, yeah, this is kind of just an example of, going down the rabbit hole and saying, all right, I want to make a system to be able to convert this stuff. I want it to be super useful. But then on that path being like, well, wait a second, why don't you just build me a faster plane? And then I can go and sort of do that. Yes, Gadi.
Thank you. So I let you go a couple minutes into the questions time, but let's see if anybody has questions for you or would like you to continue. So in the chat, you can just ask questions like, yes, more, or we'll just say thank you to JB for his presentation.
Rug pull.
Okay, we have some questions in the chat. Do you want to answer them?
Oh. Moon has one.
I can read it if you want.
Sorry, hang on a sec.
Just read it, Moon.
Have you asked LLM to combine multiple rules that are adjacent or use similar detection logic? We have tried to do this and find similar PCREs and it fails abysmally, but I suspect it's better at Sigma. So the Sigma documentation is super, super out there. And so a lot of this was more teaching it how to write the Sigma rules. And I found myself channeling my inner Yara and being like, no, use underscores, put a number at the end so you can go all of this and none of that and one of this, right? And having to go and basically train it as if the LLM was a junior analyst that you were expecting to write the signatures for, and then going and spelling all of that out in great detail. And actually I do go through a bunch of the details where, we're trying to use certain style guides, essentially, where, you know, you want it to go and write stuff a certain way.
All right, there is one more question here. If you have considered using an MCP tool for additional detection quality checks.
I've considered it. I haven't done it yet. Good idea. Definitely something I'm interested in pursuing. But this was more using some basic prompting and chaining that together with a bunch of different types of babysitting types of processes to try and get it to to give the desired outcome. But then again, the biggest thing I do have to say is it wrote a damn good Lexer that was literally 100 times faster.
All right. Well,
so
we are out of time. We could keep talking to you forever. You're amazing.